In this short video, we will cover the geometric sequence. Our formula goes like this. A sub n equals A1 times, times parentheses r to the power of n minus 1. So yesterday in class, we did the arithmetic sequence. Now here, let's introduce the geometric sequence. Both of these are sequences. However, the top one, that is arithmetic, and in the bottom, it is geometric, because in the top list, you go boom, boom, boom by adding 3. It's addition or subtraction. If you jump with addition or subtraction, you are arithmetic. In the bottom, no. Here, it is 3, but it is multiplication. You see that? That's a huge difference. So when it jumps through multiplication, your list or your sequence is geometric. So that's what we're doing today. So example, find. Let's say the goal is to find a sub 13, period. And you're given this. You are given, let's go with 4, 8, 16, and so on and so forth, like that. So while you're copying this down, I will take out a calculator. You are going to need a calculator. Like, I don't see a calculator in my backpack, but I do have Desmos. I have Desmos nearby. So I have Desmos here for when I'll need it. Okay, so to find the 13th term, identify the first term. We have our first term here, A1. Now, here, copy down your formula. It goes A sub n equals A1 parentheses r to the power of n minus 1. Some vocabulary that I should mention. This is the common ratio. That number r, it is the common ratio. Yesterday, D was the common difference. Here, R is the common ratio. So going back to our problem here, R, the common ratio is, well, let me ask you, what is going on to go from one number to the next? From 4 to 8, from 8 to 16. We are multiplying by 2. That is R, your common ratio. So now that we have A1 and R, fill out your formula and then use your formula to get your final answer. So here we go. A sub n equals A1 parentheses r to the power of n minus 1. Our formula has been activated. Now you can find whatever you want, including the 13th term. So plug in 13 in for both ends. And A13 would equal 4 times 2 to the power of 13 minus 1. And that is when you take out Desmos. So here, let me type this into Desmos. I don't know if it pops up on the Zoom, but I can see it. And it's going to say 16,384. 16,384. Final answer out the door, 16,384. Big number. And that makes sense because look, 4, 8, 16, 32, 64. The numbers are getting big. You're going 13 spots deep. It's going to be a really big number. Let's go with a 20, 5, 5 quarters, dot. So here we can readily identify the first term as 20. The question is, what is R? What is the common ratio? In the previous problem, it was 4, 8, 16. Your brains can easily detect that the common ratio is 2. But when it's not obvious, here is what you do. Take any term, and divide it by the number behind it. For example, in the previous problem, if I had gone 8 divided by the number behind it, 4, that would have revealed the common ratio, 2. So let's do that. with our question here now. To find the common ratio, take any term, let's say 5, and divide it by the object behind it. So 5 over 20, that reduces to 1/4. And that is how you find the common ratio. Take some term, divide it by the thing behind it. So let's finish this problem. Our formula would therefore look like this. 20 times 1/4 to the power of n minus 1. Who is it that we want to find? The 8th term. Okay, plug an 8 in for n. And then we get this here, 8 minus 1 equals, and just type that into Desmos. 5 over 4096. Final answer out the door. How about a 3 and then comma blank, comma blank, comma blank. And then the last one, let's go with 48 over 2041. So we need to fill in the blanks geometrically, meaning from 3 to here to here to here, we're multiplying by the same thing. So here is one way of doing this. We know that to get to the first spot, you have to go 3 times some mysterious number r. To go to the next spot, you have to go 3 times r and then r again. So r squared. The next one would be 3 times r to the third. And then for the next one here, it would be 3 times r to the 4. However, there's already something occupying this last spot. So what you do is you set them equal to each other. You set this equal to that. That's going to tell us r. Once we know r, we can go back here and fill in all of the blanks. So I need you to create the equation that says this equals this. So let me get some space for myself here. 48 over 2041. Solve for r. Solve for r. So get rid of the 3 by multiplication of 1/3. Multiply both sides by 1/3, because over here, the third cancels with the 3. So we have r to the power of 4 equals, and then multiply these guys on a calculator. I believe it'll be 16 over 2041. Now, on your calculators, to get r alone, you take a 4th root. A 4th root. You take a 4th root of 16 over 2041. You get back exactly r equals 2 over 7. R equals 2 over 7. So now take that r and plug it in here, here, and here, and you'll get your final answer. So it should be this. 3 comma, and then in the first one, you multiply 3 by 2 over 7. You get 6 over 7. And then do that again. You get 12 over 49. You do that again, and then you multiply that again, and you get, of course, the given final term of 2041. Yeah, so that was a brief introduction on the geometric sequence. On Monday, we'll do the geometric series. But for now, let me stop. Let's go outside, and let's take those 2 huskies out for a walk. What's up, guys? What you doing? Morning. Down to the camera. Kobe, say hi. Khaleesi. Khaleesi, say hi, girl. Say hi, guys. You're on camera. Tell them you're thirsty.